Water. Water is an extraordinary substance. Water is, as I think we all recognize, water is essential to life. We can't live without water, right? And when scientists are looking for life on other planets, one of the things they're looking for is the presence of water. Because without water, we have a hard time imagining how life could exist. It has a low molar mass, and yet it's a liquid at room temperature. And that's weird. I'm just going to jump ahead to this graph. So we saw a graph like this earlier in this chapter. This one has a little bit more information. So the red line here, these are hydrides of the group 4 elements. And in the green, we have group 7 elements, and in the yellow, group 5, and in the blue is group 6. And so we see this trend here, whereas the period of that central atom increases, the atoms are larger, they're more massive, and we see that the boiling point increases. And that follows the ideas of stronger dispersion forces for larger molecules. But if we look at the other end of this, this is just doesn't seem right. These three are much higher than the boiling point for methane. What kind of a molecule is methane? Is it polar or nonpolar? It's nonpolar. It's just got carbon and hydrogen bonds, and there's no lone pairs. What about ammonia? Ammonia is polar. Does it have hydrogen bonding? Yeah. HF, is that polar? Does it have hydrogen bonding? Yep. Water, is it polar? Yep. Hydrogen bonding? Yep. So these are all polar, and they have hydrogen bonding, and that's why their boiling points are so much higher. So water is a liquid at room temperature, and that's very unusual. Even among these substances, other substances that have hydrogen bonding, HF boils around room temperature, and so that's not really a liquid at room temperature either, and ammonia is a gas. So water is very unusual in that regard. It's the main solvent in living organisms. There are some other solvents in your body. Lipids dissolve things as well, but mostly it's water. And you look in the environment, and it's almost entirely water as the solvent. Almost every liquid that we encounter in everyday life has water as the solvent. Milk. Like, well, that's not water. Yeah, but it's water with stuff in it. Soda. Even gravy has water in it. I mean, just anything you can think of. An exception would be pure alcohol, but we don't even drink pure alcohol, right? Straight vodka or something is not 200 proof. It's maybe 100 proof, which is 50%. So water's everywhere. Water's unusual in that it has a high specific heat capacity that moderates our climate, that helps to keep the environment from getting too hot during the day and too cold at night, sort of a buffer for us. And water expands upon freezing. Most substances, when they freeze, become more dense. They become smaller. They contract. Water actually expands as it freezes. And that's because the little water molecules arrange in this open hexagonal crystalline pattern, which is why we have beautiful snowflakes, but that causes them to expand. And that causes a lot of different effects in the environment. Here's one of them. Here's a nice head of lettuce, and here's a similar head of lettuce that got into a part of the refrigerator that is too cold, and it froze. And you can thaw that out, but it's never ever going to be the same. What happened is, when it froze, the water in the cells expanded and burst the cell walls. And that happens in the garden, too, and things break, right? And it kills the plant. Some plants are much more tolerant to that than others, but most of them just kind of wither up like that. That's why you don't buy frozen salad and then bring it home and thaw it out and have a lovely salad. Doesn't work, right? This also keeps the lakes from freezing solid. I grew up in Minnesota and Iowa where it gets genuinely cold in the winter. And so the surface of the lake freezes. But because ice is less dense, it stays at the surface. If ice was more dense, as it froze, it would sink to the bottom and the lakes would freeze solid. There'd be no fishing in Minnesota, which would be just horrible. So it keeps the lakes from freezing solid. But it'll also do things like break your pipes. So in Minnesota, if your power goes out when you're on vacation in the winter and your house gets cold and your pipes freeze, when water freezes, it expands and it will burst metal pipes. And then you've got a flood. That also happens if you're trying to freeze a water bottle. You maybe have experienced this. Do not put a full water bottle in the freezer and forget about it. If it freezes solid, it's going to burst the bottle. If you're going to freeze something solid, you need to have some space in there, some airspace, so that it can expand. And still, you might end up breaking it. Water pollution. So water is essential to life, and we need to have clean water. I'm not going to quiz you on this, but I just want to give you a little overview. There are two broad categories of water pollution. Biological contamination. This is things like E. coli and other microorganisms that cause diseases. This happens when, say, your drinking water source gets contaminated by water runoff from a pasture where cows are. Where there's cows, there's cow pies, and there's nasty stuff in there, and that can run off. And when we got these issues of like various sorts of food poisoning with lettuce and salad ingredients and strawberries, what's happened is that the field has been watered with water that's been contaminated by runoff from pastures. So that's not good. You can treat this, though. You can treat it chemically or by boiling it, and you can kill the organisms, and so that's not so bad. You know, you're up in the mountains, and you want to drink water out of the stream, the safest thing would be to boil it or use some sort of sterilizing tablet. Then you have chemical contaminants. These are non-living organisms. They're not living organisms. Things like fertilizer runoff, even prescription medicine that's been flushed down the toilet, various things like that. Runoff from the asphalt. So cars, right, they drip oil, and then that water runs off, and it carries some of those chemicals into the streams. And you can't get rid of contaminants like this by boiling the water. There are some volatile contaminants that will go away, but the non-volatile ones won't. In fact, by boiling the water, you actually concentrate the contaminants. So if you're dealing with contaminated water, you have to understand what kind of contamination you have so that you can deal with it. Any questions?